Welcome to this video. I'm going to solve a problem involving the kinematic equations. Okay, what are the kinematic equations? Oh, it's these four. But wait a second, weren't there other equations that had y? Oh yeah, that's right, they had y instead, some others. And if I ever have a problem where there's y motion along the vertical axis, I'll just change the x's to y's. And last thing, why are these the kinematic equations? I thought they were the constant acceleration equations. Well, they just have two names, so we can call them both. Alright, let me read the problem. A jet accelerates uniformly. Oh, I know what that means. That means I can use my four equations. Whenever you have uniform or constant acceleration, and this acceleration is uniform, it says right there. Whenever you have that, you can use the four equations. So I'm starting to think about these. Okay, it accelerates uniformly for 5 seconds at negative 15 meters per second squared. Over this time interval, the jet travels 350 meters south. A, determine the jet's velocity at the beginning of the acceleration. B, determine the jet's velocity at the end of this acceleration. Alright. Well, there's a lot of information. Let me make a list of givens, just so I can organize my thoughts. So it accelerates uniformly, use the equations, for 5 seconds. That's a given, that's a value. I've just been given the time, because it's in seconds. That's how I know. Okay, it accelerates uniformly for 5 seconds at negative 15 meters per second squared. It kind of sounds like a velocity, but let me look at the unit. The units are meters per second squared, so that has to be acceleration, not velocity. So the acceleration is negative 15.0 meters per second squared. Negative, does that mean to the left? Let me keep reading. Over this time interval of 5 seconds, the jet travels 350 meters south. Oh, it's south. So now I'm looking at north, south. North is going to be positive, south is negative. Okay, so this here, that just means south. Okay, determine the jet's velocity at the beginning of the acceleration. Well, I want velocity, but I have two velocities. There's the initial velocity and the final. So which one is this asking for? At the beginning, oh, that's the initial. So, oops, I forgot to write down this given. My displacement, delta x, is south. Oh, whoops, it's south, so let me make that delta y, because it's south along the y-axis. And it was 350 meters. Let me keep those sig figs. 0.0, I'll add that, keep the sig fig. And south is negative, because it's down. Alright, part A was, what was it? Determine the velocity at the beginning, that's VI. Part A says find VI. So A is V, the initial velocity equals, question mark. I'm not going to write the arrow. I could if I wanted, but I'm just not going to write it. The context here is enough. If you don't write the arrow, the context is still sufficient to indicate we're talking about velocity, not speed. And part B says, determine the jet's velocity at the end. At the end, so that's the final velocity because it says end. And again, I'm not going to write the arrow. That's perfectly fine. You don't have to do that. Okay, well, let's see. Let's look at this. I've been given three different numbers, values, and I've been asked to find VI for part A. So I'll do A first. Well, I've been given these three values, time, acceleration, delta y. I'm looking for VI. Let me look at my equations. Can I use this equation to solve? Well, I'm looking for VI, that's my unknown. I know delta x, it's actually delta y. I know time, oh, but I don't know VF. I can't use this equation because I don't have two, I have two unknowns, and I need to have just one unknown. So this equation doesn't do it, doesn't cut it. Let's see, let's look at this one. Delta x, I know delta x. VI, that's my unknown for part A. Time, I know the time. I know the acceleration, there it is, right? Negative 15. And I know the time. Okay, so I can use this equation because it has the three givens. It has delta x, VI, the three givens are delta x, time, and acceleration. And it also has my one unknown. So I'm going to use that equation. Alright, let me write the equation. Here's what I'm going to do. To be very, very clear in my work, I'm going to rewrite the equation so I don't mess it up. But I'm going to put a y instead of delta x equals vi times the time plus 1/2 acceleration times the time squared. Is the squared for just the time, or is it for the acceleration and the time? Maybe also the 1/2. Oh, it's just for the time. Only time is squared. There's like parentheses right here. Okay, so let me proceed. Delta y, I'm going to substitute in my value of -350. I'll keep the sig fig. I'm not going to write the unit. I don't need to worry about it. Vi is my unknown, so I'm not going to plug in anything there. I'm multiplying Vi by the time, which is 5 seconds. That's what my chart says. Oops, I should keep sig figs. Plus 1/2 acceleration times the time squared. So what's my acceleration? Let me look at my chart. -15. And what's my time? Here it is. It's 5 in my chart. It's really nice. Wow, I really like having this chart because then it's really easy for me to just get the values in my equation and I'm not messing anything up. You know, I don't have to look back and try and think, was that displacement? Was this velocity? What was that again? Yeah, the chart helps me. Okay, now I have to solve for Vi, my unknown. Well, I want to isolate it. That means get it by itself in the numerator. So first, I'm going to get rid of... should I get rid of the 5? Or should I get rid of this stuff? Well, if I try to divide by 5, I'll have to divide the entire left and right side. So that could work, but I don't really want to deal with dividing. I don't want to distribute the division to both terms. So instead of dividing by 5, I'm going to get rid of this first. How do I get rid of it? Well, it's being added, so I'll subtract it. Minus 1/2, I'm going to subtract. Well, let me go ahead, I guess I'll just go ahead and calculate that first. 1/2 times -15 times 5 squared, and my calculator says this is minus 187. So I've got 5 Vi minus 187.5. I switched the order of these because when I write unknowns, variables with their numbers, I usually write the coefficient out front, so I just switch the order. Alright, on the other side we have minus 350.0. I'll keep that sig fig. And then I need to add 187.5 to both sides. Whatever you do to the left, you have to do to the right. It's the golden rule of equations. So this cancels out. Negative 187.5 plus positive 187, that's 0. Oops, those don't cancel. What is that? So 350 minus 187.5, this is negative 162.5 equals 5 Vi. Okay, so the next thing I have to do is divide both. I have to get rid of the 5. It's multiplied with Vi, so I'm going to divide both sides by it. 5's cancel out. And the right side is just Vi, that's what I want. The left side is negative. I'm going to divide my calculator, negative 32.5. I haven't included units throughout, but now I have to go back and add the units in. Well, as long as you use seconds, meters per second squared, and meters, the velocity always comes out as meters per second. And as a separate exercise, we can prove that. We're not going to do that here. Alright, there's my answer. B, part B. I should check sig figs, right? I should check sig figs. When I multiply the 15 and the 5.00, this was 15.0, that's 5.00. When I multiply these, the answer should have 3 sig figs, and that means this would just be 188. And when I add 188 over to here, if this were 188 instead, 188, I would have rounded my answer to the ones place, which means it would have had 3 sig figs. It would have been 163, negative 163. So 3 sig figs, and then the 5 was actually 5.00. Whoops, I left that off, didn't I? So when I do 163 over 5.00, the numerator and denominator each have 3 sig figs, so my answer should have 3. Okay. Part B. Find VF, final velocity. Well, now I have these 3 things that I know, but I also know VI. So let me just find an equation with VF. Here it is. I can use this equation because I've got my one unknown. I know VI, I know A, I know delta X. But if I look at the top one, the equation one up, I know A, I know VI, I know T. So you could use that to find VF. Even this equation, we know delta X, we know VI, we know T, so we could use that to find VF because there's only one unknown. So once you find part A, you have your choice, your pick of equations. I'm going to use the equation, I'm going to use this one on the bottom because there's the least amount of rearranging. Okay, so let me use that equation. VF squared equals, I write the equation down, I don't want to mess it up, so I'm going to write it down again. VI squared plus 2A delta X. Okay, so let me plug in my givens. VF squared. What do I know? I'm going to plug in for VI, for A, and for delta X. VI, I got my answer was negative 32.5. Oh, but look at this. It's squared, so when I square the negative, it's going to go away, so I'll just be squaring 32.5. Negative times negative is, negative 1 times negative 1 is positive. Alright, the acceleration, that's the next thing to put in. I substitute in the value of negative 15. Negative 15. Oops, I should do negative 15.0 for sig figs. And then delta X was negative, oh, it's delta Y, because it's along the Y-axis. So delta Y, and the answer was, the value was negative 350.0. Okay. Alright, so let me calculate this out. And then I'm going to have to square root both sides, because it's VF squared. So 32.5 squared, I know my answer has to be positive. It's 1056.25. And then I'm going to be adding a negative number. Oh no, look, the negatives are going to cancel out. Okay, so 2 times times 15 times 350. This is plus 10500. And what is VF squared? VF squared is, I add these up, and I get 1155.6.25. Wow, is that my answer? That's huge. Oh, it's not my answer. Look, I have to square root both sides. Okay, let me square root both sides. Oh, but wait a second. When I square root, there are 2 solutions, positive or negative. Got to think about that. So VF is positive or negative. Well, what's the square root of this? It's 107.5. The units are meters per second because it's velocity. Well, which answer? Is it positive or negative? Let me go back to the question. It was going, my answer to A is negative 32.5. So it was moving in the negative southward direction, and then it accelerated in the southward direction. That means it's still going south. It's like, here's my plane, right? Here's my plane, and it's moving this way, and then it accelerates so that it's going south still, but just faster. So it still is going south, so let me just erase the positive. I'm going to choose the negative solution because that's what makes sense, right? Okay, now sig figs. Well, this is 3 sig figs, so when I square it, the answer would have 3 sig figs. It would just be 106, and then that would be a 0. And these have 3 sig figs each. The 2 has no sig figs. It's an exact number. So my answer, oh no, this has 4 sig figs, and this has 3. So when I multiply, I give it the fewer number of sig figs, 3. When I add these, I'm rounding to, that's the tens place. This is the hundreds place that it's rounded to. So I round this to the hundreds place, which means it has 3 sig figs. When I square root, my answer has to have the same number, 3 sig figs. So I have to round this to minus 108. There we go.